Welcome back, everyone. It's time for another deep dive into biochar.
Always exciting.
Readers over at Biochar today have been busy pointing us towards some really fascinating stuff.
Yeah, some pretty interesting things popped up this week.
We're going to take a closer look at the stuff that's been getting people talking.
Exactly.
Well,
So this week, we've got a look at a patent for a new graphite production method.
okay.
There's a study on biocomposites that's been making the rounds.
Interesting.
And then we'll wrap things up with some research on biochar and its effect on soil.
Yeah, sounds like a good lineup.
Mm-hmm.
So let's jump right in.
Sure.
First up, biochar is making a name for itself outside of the world of soil.
Uh-huh.
There's this piece of news that's been generating a lot of buzz about CarbonScape.
Oh, yeah, CarbonScape.
They secured a U.S. patent recently,
They did.
and it's for a very interesting method for producing graphite.
And the main ingredient you want to guess?
Let me guess.
Yeah.
Biochar.
Biochar, exactly.
So the same stuff that we often use to enrich soil is now being looked at to create this high-value industrial material.
Uh-huh.
I mean, that's a pretty significant shift.
It is.
Because when you think about traditional graphite production,
Yeah.
it's pretty environmentally intensive.
It is quite energy intensive, and it can have some environmental impacts.
So this patent is kind of suggesting that there might be a greener way
Potentially a much greener way.
to produce it
Yeah,
using biochar to kind of leverage that carbon that's locked away in it.
exactly. Taking advantage of that carbon-rich nature of biochar.
And graphite is in so many things.
It's crucial.
It's in batteries and electronics.
Yeah, you think about all the different industries that relied on graphite, from electronics to batteries, even things like lubricants.
So having a more sustainable source could have really positive widespread impact.
Absolutely, a ripple effect across a lot of industries, and that's why this patent is causing such a stir over at Biochar today.
Yeah, people are really seeing the potential here. So
Yeah.
from industrial materials to more everyday items.
Right.
You found this really interesting piece of research about biochar and biocomposites.
Yeah, this one really caught my eye. It's called Can Biochar Fillers Advance the Properties of Composites? Early Stage Characterization and Life Cycle Assessment of Novel Polyamide Biochar Biocomposites.
It's a very thorough title.
It's a mouthful, but it's packed with information.
It is.
And the researchers in the study, they were looking at combining a bio-based plastic
Yep.
called polyamide 1010.
Polyamide 1010.
Yeah, have you heard of that one?
I have not.
It's actually derived from castor oil.
Oh, wow. Okay.
So it's already a bio-based starting point, and they combine that with biochar that was made from pine wood chips.
So they're essentially mixing two sustainable materials.
Exactly, that's
Yeah.
the idea. They want to see what happens when you bring these two together.
What were they hoping to find out?
Well, they were really interested in seeing if adding biochar as a filler would change the strength of the plastic
Okay.
and its properties overall, like how it behaves.
Make-
And really importantly, they wanted to know if it would make the whole thing more environmentally friendly.
Of course, that's always a big question.
Absolutely.
And they use some pretty high-tech methods to really get down to the nitty-gritty of these biocomposites.
Yeah, they did. They delved deep.
Like, what did they use?
Well, one of the techniques they used was scanning electron microscopy.
Wow.
It's like a super powerful microscope. It allows you to see things at an incredibly small scale.
So what did they observe at that microscopic level?
Well, what they saw was that the biochar particles were really well dispersed throughout the polyamide.
Okay.
Like they were mixed in really evenly.
Gotcha.
And not only that, but they saw a strong connection between the biochar and the polyamide.
So they were really bound together well.
Exactly. And that good mixing, it's really important for how well the final material performs.
I can imagine if they're not binding together properly, you wouldn't get the improvements you're looking for.
Precisely. It's all about that interaction between the materials.
So what kind of performance boosts did they see?
Okay, get this. The mechanical tests showed some really impressive results.
Okay, go on.
They found a 44% increase in tensile strength,
Wow.
which basically means it can withstand a lot more pulling before it breaks.
That's a big jump.
It is, and it gets even better. They saw a 110% increase in tensile modulus.
110%.
Yeah, that's not a typo.
Wow.
That's more than double.
That's huge.
And tensile modulus is basically a measure of stiffness. So it tells you how much the material resists stretching or bending.
So just by adding biochar, it became way stronger and stiffer.
Precisely. It's like giving the material a backbone.
That's pretty remarkable. And any other benefits?
Oh, yeah. The benefits didn't stop there. The thermal stability also got better.
Okay.
So the material can withstand higher temperatures before it starts to break down.
Interesting.
It went from 460 degrees Celsius to 474 degrees Celsius just by adding biochar.
So not only is it stronger and stiffer, but it can also handle more heat.
Exactly, and that opens up a whole world of possibilities for using it in more demanding situations.
Absolutely, that makes
Yeah.
sense.
They also did some other tests that confirmed that the biochar was really contributing to this increased stiffness and resistance to deformation.
Okay, so it's looking good in terms of performance.
It is.
But what about the environmental side of things?
Right. Well, that was a really important part of the study.
Yeah.
They did something called a life cycle assessment, which is a really comprehensive way to look at the environmental impact of a material.
Okay.
They look at everything from the raw materials to the production process to the disposal at the very end.
It's the whole picture.
It is. And what they found was pretty remarkable.
What do they find?
The biocomposites had a 65% lower carbon footprint
65% lower.
compared to the pure bio-based plastic.
It's a huge reduction.
It's significant, and it's one of the reasons this study is resonating so much with the Biochar Today readers. They're really interested in sustainable solutions.
Yeah, that's a big win for the environment.
Absolutely.
So what was the main reason for this big drop in the carbon footprint?
Well, essentially, they replacing some of that polyamide, which has its own environmental costs, from producing the castor oil,
Right.
with biochar, which in this case actually has a lower impact and can even sequester carbon.
So you're essentially taking carbon out of the atmosphere
Mm.
and locking it into these materials.
Yeah, it's a pretty neat trick.
It is. It's a great example of how biochar can contribute to greener materials.
For sure.
Were there any downsides to adding the biochar?
Well, the study did point out a couple of trade-offs.
Sure.
They found that while the material became stronger and had a lower carbon footprint, it also became a bit less flexible and less resistant to sudden impacts.
So stronger, but potentially more brittle.
Yeah, that's a good way to put it. It's something engineers would have to think about carefully depending on what they're designing.
Exactly. All depends on the application.
Right. The researchers also compared their biocomposite to other plastics out there, like commercial ones, and some that are still in development.
Right.
And they found that their biocomposite often did better in terms of carbon footprint and a thing called eutrophication, which is basically when too many nutrients end up in water and it can cause problems.
Yeah, I've heard of that.
But they did emphasize that there's still room for improvement.
Of course, always room for improvement.
Right.
So it sounds like they've made some really promising progress.
They've laid a really good foundation for future research in this area.
And for the Biochar Today audience, this is really interesting because it shows how biochar could be used in everyday products.
Absolutely. It's about moving beyond the soil and finding new applications for biochar.
Exactly. All right, so the final piece of research takes us back to biochar's roots.
Back to the soil.
Back to the soil, its interaction with soil and fertilizers.
Right. This study, it was called Effects of Biochar and Nitrogen Fertilizer on Microbial Communities, CO2 Emissions, and Organic Carbon Content in Soil.
Catchy title.
Yeah, well, they get right to the point.
Yeah.
And this was a 3-year field experiment on wheat fields in China.
3 years. That's a good long-term look.
It is, and these long-term field studies, they're really crucial because they give us a better understanding of what really happens when you use biochar out in the real world.
Yeah, makes sense.
Not just in the lab.
So what exactly were they testing in these fields?
Well, they had 8 different groups, and they were basically varying how much nitrogen fertilizer they used and whether or not they added biochar.
Oh.
So they had everything from the standard amount of fertilizer to a reduced amount, and they tested those with and without biochar.
So they were really trying to get a good handle on how biochar interacts with different levels of traditional fertilizer.
Exactly. It's all about those interactions.
What were some of the key takeaways from this research?
Well, one of the big findings was that combining biochar with nitrogen fertilizer led to increases in both active and total organic carbon in the soil.
So that's good news.
It means more carbon is being stored in the soil, which is what we want.
Yeah.
But what's really interesting is that they found the biggest boost in soil organic carbon when they used biochar, with 15% less nitrogen fertilizer than usual.
So less fertilizer, more carbon in the soil?
That's right. It suggests that we might be able to use less synthetic fertilizer while still improving soil health.
That's something the Biochar Today readers would be really keen on.
Absolutely. They're always looking for ways to make agriculture more sustainable.
Okay, so that's a really positive finding.
It is.
Less fertilizer, more carbon storage.
Mm-hmm.
But
there was a bit of a twist.
Uh-oh.
They also observed that when you add both biochar and nitrogen fertilizer together, It tends to increase the amount of CO2 being released from the soil.
Oh, that's interesting because biochar is usually associated with taking carbon out of the atmosphere.
Right. It's a bit counterintuitive.
So why might that be happening?
Well, the researchers think it might have to do with the microbes in the soil.
Okay.
They think that the biochar and the nitrogen together are changing the activity of those microbial communities.
The tiny little creatures that live in the soil.
Exactly, and they're responsible for breaking down organic matter. And when that happens, CO2 can be released.
So biochar is not just locking away carbon, it's also influencing this whole ecosystem in the soil.
Right, it's playing a much more complex role.
It's a reminder that there's a lot going on beneath the surface.
Absolutely, we're just beginning to scratch the surface of understanding these interactions.
So they saw that there were changes in the microbial communities.
Yeah, they observed some shifts in the types of microbes present.
Were there any other notable observations about how the soil changed?
Yeah, they also found that when they used biochar on its own without any extra nitrogen, the microbial activity in the soil was generally lower compared to the groups where they combined biochar and nitrogen.
So it seems like the biochar might work best when it's paired with some level of fertilization.
Yeah, at least in this specific wheat field, it seems like that might be the case.
So another interesting point for farmers and researchers to consider.
It's all about finding the right balance for different situations.
Absolutely. And were there any other physical changes to the soil?
They did. They found that adding biochar helped to reduce the bulk density of the soil.
Okay, and what does that mean?
Well, it basically means the soil becomes a bit less compact.
Okay.
And that's a good thing because it can improve things like water infiltration and root growth.
So the roots can spread out more easily.
Exactly.
So if you were summarizing this study for someone reading biochar today, what would be the key takeaways?
Well, I'd say the main message is that in this particular wheat field, combining biochar with a slightly reduced amount of nitrogen fertilizer seemed to be the best way to increase soil carbon while minimizing those carbon emissions.
Okay.
But they did stress that more long-term research is needed.
Of course, always more research to be done.
Right, because these findings might not apply to all situations.
Right, different crops, different soil types.
Different climates.
Yeah.
All of those things can play a role.
So it's not a one-size-fits-all solution.
Exactly. It's about understanding the nuances.
Like always. So as we've seen this week, the world of biochar is pretty diverse.
It is. There's a lot going on.
From the excitement about this new patent for greener industrial materials
Right.
to the really in-depth research on improving everyday plastics, and then this nuanced understanding of how biochar interacts with soil.
It's a dynamic field.
It is.
Yeah.
And it's clear that people are really interested in it.
Absolutely. And Biochar today is a great place to stay up to date on all the latest developments.
Absolutely. It's a fantastic resource.
Mm-hmm.
Well, thanks for joining me for this week's Deep Dive.
My pleasure.
And we'll be back next week with more from the world of biochar.
Looking forward to it.
Until then, keep exploring.
And keep those questions coming.